Okay, Mr. Hunt here again. I'm moving on to quadrilaterals, and then we'll finish up with a little bit of just review for segments and ratios. Now, this will be new. We learned about quadrilaterals, but now we need to verify on a grid. Okay, is it a parallelogram? Is it a rectangle, a trapezoid, all of those shapes? So let's start with this is on page 10, showing or proving a quadrilateral is a parallelogram. You have many choices, right? We did a whole section on this, like um, is it a parallelogram? Well, it is if the opposite sides are congruent, or the opposite angles are congruent, or diagonals bisect each other. So I gave you a few options that all of these work. There are a couple more, but these are some of the best ones. My favorites are just opposite sides parallel or opposite sides congruent. Those are probably the easiest ones. So let's do number. Nope, there we go. Let's do number 1. Prove that it's a parallelogram, or sometimes I'll say determine if it is. Okay, again, I'm going to try and plot these good, but we'll see. 4, 3, 2, -2, -4, -2. You might have an idea, yes or no, it is or it is not, but let's check and see. So, in my opinion, the easiest way is just to find the slopes, because checking the slopes will see if it's a parallel sides. You have parallel sides, and if it's a parallelogram. Slope here and here, they're horizontal, so it's 0. Rise 0, run anything, like 5 or something. What is this? 6 maybe? Yeah, 6. Okay, so that's 0. So horizontal lines have a slope of 0. Okay, the other two lines look similar. Let's just do the rise over run here, and I get 5 and 2. All right, and same thing here, it'd be up 5 over 2. So both of them have a slope of 5 halves. The opposite, so yes, it is opposite sides parallel. I'm going to have to give reasons for this, or show your work as well. Explain. Okay, on this, now another way you could have done it is opposite sides congruent. I think on my notes key, you can see that. I also showed that these lengths were each 6. And then if you do Pythagorean theorem, 5 squared and 2 squared, you get radical 29 both times, so opposite sides are congruent. The next one, previous one won, this is number 2. Rectangle. Now, there were two things besides, okay, rectangles are parallelograms. So really what we have to do is show it's a parallelogram first, and we'll often look at the sides or angles. So we'll kind of do that in the process here. So, but then what we got to do, one of two options, show the diagonals are congruent, they're the same length, or show it has one right angle after you've shown it's a parallelogram. Okay, so, or show it has 4 right angles, but so math, quadrilateral math, -3, -2, 4, 2, 2, 4. Yeah, I think they got that right. 3, 0. Okay, so it looks like that. Again, what I'm going to do is look at the slopes. And I need these to show it's a parallelogram, but I also need it to show it's a rectangle. So I do the slope here. It looks like up to right 6. Same down here, 2 and 6. So we'll simplify that. They both have a slope of 1/3, so these are parallel. I forgot to put the arrows on the last page once we confirm they're parallel. But both parallel. They are parallel because 2 and 6 both have a slope of 1/3. Do the other two sides. This one and over, it looks like down 4, right 1. Same over here. So they both have a slope of down 4 and -4 over 1. Okay. So then opposite sides are parallel, so that's good. So I'll put the arrows here. So it is a parallelogram. We've shown that opposite sides are parallel, similar to number 1. Is it a rectangle? I'm going to use method number 2. You just need, we did a right triangle with this. We need to check one pair of adjacent sides and see if their slopes are perpendicular, because that would make a right angle. Adjacent sides, 1/3 and -4. Are they perpendicular? No. So if this was -3, they're very close. If this was -3, it'd be a yes, or if this over here was a 1/4, it would have been a yes. Very close, but they are not. So I'll put not a rectangle. Capital R is my rectangle. You also could have, so here's the other thing you could do if you're more into the diagonals, because rectangles have congruent diagonals. Draw on the diagonals. You then have to do Pythagorean theorem with that one and another triangle with Pythagorean theorem with those two. And just see if you get the same thing. You will not. So it's a no. Okay, next one we'll show it's a rhombus, and then we'll do one square, or determine if it is. I guess this one says prove, so it's going to be a lot of similar things. I'm going to first show it's a parallelogram. Yeah, I do say that. Show it as a parallelogram first. Same with the rectangle. First show it's a parallelogram. Look at the opposite slopes. Okay, so after we show it's a parallelogram, again, there could be more, but here's 3 good methods, and they're based on, same as rectangle, based on the new properties for a rectangle or rhombus. We can show one of these. We can show the diagonals are perpendicular, so they intersect to make right angles. Adjacent sides are equal. I put distance formula. We do Pythagorean theorem, so you can cross off distance formula, just Pythagorean theorem. Or show that all 4 sides are equal, they're congruent, the same length. I prefer method 3. I could also do method 1 isn't too bad. So any of these will work. So let me draw on, there's -2, 3, 2, 6, 7, 6. I think I got that, 3, 3 right there. Okay, so show it's a rhombus. So basically I need it that it's parallelogram first. I'm thinking the easiest method might be method 3. Because we can show it's a parallelogram. Usually I do the parallel opposite sides. I'm going to do opposite sides congruent. If I just count along here, this is 5, and that's 5. Horizontal lines you can count. Then this is 3, and this is 4. And Pythagorean triple, that's 5. Same here, 3 and 4. So that's 5. So all of a sudden, not only is it a parallelogram because opposite sides are congruent, it's quickly a rhombus. Oh, I do little r, h. It is a rhombus because all 4 sides are congruent. Okay, the other thing that I suggested, method 1 would be good as well. Draw in the diagonals and just do the slope of each of those lines. So count down and count up and over here. And you get that they are opposite reciprocal slopes. Okay, next, number 4, show it's a square. So basically a square, remember our diagram, it's you got parallelogram and then you got rectangle and rhombus, but then these two go to make a square. So basically show it's a rectangle and it's a rhombus, and then it'll be a square. So what do I say? I think I said that, yeah, the first one, show all 4 sides are congruent, rhombus, and it's opposite reciprocal slopes, rectangle. You can also do something with diagonals bisect each other. Oh yeah, okay, you can look at the diagonals. This is a good one. Show the diagonals bisect each other, show they're equal, then it's a rectangle, and show they're perpendicular, it's a rhombus. Both are good. For me, I just say, oh, it's a rectangle and a rhombus, so I like the first one a little better. Okay, so I'm plotting my points. 7, -1, 3, -4. Hopefully I got those all right. Show that it is a square. So first I'm going to do a rhombus, same as the last one. I'm going to look at the side lengths. These here, if I do all 4 Pythagorean theorems, it's 3 and 4 all the way around. Okay, and so they all end up being 5. So it's kind of the same as before, the setup. All 4 sides are congruent. So it is a rhombus. Then I need to look at the slopes, and you can see, oh, and opposite sides are congruent, so it is a parallelogram. Oh, hit the wrong button. There we go, parallelogram. So it is a parallelogram as well. So let's look at the adjacent slopes, consecutive sides, the adjacent ones, see their slopes. This one right here was up 3, right 4. This one right here, so I'm on this one down here, down 4, right 3. They are opposite reciprocals. So it means it's perpendicular. So this is a right angle. And in a parallelogram, if you have one right angle, you have 4. So it's perpendicular, so yes, it's a rectangle. And since it's both a rhombus and a rectangle, therefore it's a square. Okay, so I'm going to finish up with just a square, trapezoid, and then a little review of segment ratios, like partition and finding a ratio of segment lengths. Reason is, they've released questions like that. You know, it seems like it's going to be a question that they like. Let's hammer it home, make sure we know it. Okay, so let me bring back up a grid. Okay, so trapezoid. Well, trapezoid is one set of opposite sides parallel. And you've got to show the other set of sides is not parallel. So only one pair. And then to show it's an isosceles trapezoid, show that those legs, well, there's two ways. The non-parallel sides, the legs of the trapezoid, show they're congruent. I like that one. That's method 2 on here. Method 1 is also good. A property of isosceles trapezoid is the diagonals are congruent. Again, Pythagorean theorem. I should get rid of distance formula there. All right, so we got quadrilateral milk, -3, -1, -2, 3. See, it's hard to draw in here. 2, 4, 5, 1, 2, 3, 4, 5. Okay. Prove that it is a trapezoid, then determine if it's an isotrap. All right, so there's trapezoid. We got to look at the slopes. And right here, I'm looking at this slope, and I'm doing this for that slope. So it looks like here I get 1 and 4, and here I get 2 and 8. Again, pause the video, and you can try these out on your own. 1/4, and then we get 2/8, which reduces, divide by 2 to 1/4. So those set of sides are parallel. The other ones we should check. Now this one's positive slope, this one's a negative slope. They're not parallel. So it is a trapezoid. We knew that was going to happen. One set of opposite sides parallel. Sides parallel. Now, is it an isotrap? I think the easiest way is just to look at the green ones and see if they're congruent. But again, if you want, you could also draw in method 1. You could draw in the diagonals. You could draw those in and find the lengths of those two. For me, though, I'm just like, we already have the other sides. Let's just go ahead and find those. Okay, let me change colors. Actually, let's go back here. Okay, so again, I'm doing Pythagorean theorem, a lot of that. So, excuse me. Here we get 4 and 1. So 4 squared, 1 squared equals c squared. Do the work, you'll get radical 17. Here, it is 3 and 3. Now, I could do the work, 3 squared, 3 squared. Okay, you get radical 18. Or, remember, when it's isosceles, we made a right triangle, and it's isosceles. It's therefore 45, 45, 90. So I could have saved myself a little time and just said it's 3 radical 2, which is equivalent to radical 18. In any case, these two, they're close, but they are not equal. So because of that, is not an isotrap. Okay, that was fun. Let's go. So the last two is just a review, segment ratios review and partitioning. So these don't have numbers. Last one was 5. These two don't have numbers. So last two, just plot it. I can't seem to, there we go. -2, -3, 0, 1, 4, 9. Okay, I think up here's, I hope that's 9. We'll see. All right, good. By the way, I think we've seen this one before, so try not to look back, because I did repeat this one. All right, so it says find, okay, this was R, this was S, and this was T. So once RS over RT. So I used to only go with one method. Now we've kind of discovered a second method. The one method that I used to teach only was this, just do Pythagorean theorem for RS. Looks like I'm getting 4 and 2. Okay, again, do the work here, radical 20. And then repeat for RT. Be careful what they're asking for. They want RT, not ST. So this looks like 12 and 6. Okay, and you get radical 80. And so then they want, RS. Okay, so radical 20 over RT, radical 180. Put that in your calculator. Don't cancel. You can't cancel the 20 and the 180. Well, you could create one square root, but put that in your calculator. You get 0.3 repeating, so it's 1/3. Now the other way that we figured out this year, I really like this method as well. Let me change a different color. Let's go purple here. Is you count up and over to this point. You repeat. It's kind of the partition method. You do it again. That was up 4, right 2. So I go up 2, 3, 4, right 2. Up 4, right 2. So there's 3 equal segments there. And then you just see which ones do they want. They wanted RS, there's 1 segment, to RT, there's 3 segments. Might be easier. Sometimes the questions are decimals though, so the Pythagorean theorem way might be a little easier, but it's up to you. Okay, last one. Partitioning a segment. I put a little review of what we do here. I'll talk through it as well. But -2, 4, 3, -6. I think I got that there. Ratio of 3 to 2. So it's like 3 segments to 2 segments. So that's a total, I don't remember exactly what it is, that's a total of 5. So what we're going to do is break up this segment into 5 equal pieces. Okay, so you Google this, there's a million different ways you could find, but I think this is the easiest we found, kind of that counting one that we did in the last one a little bit. You count each of these segments. Oh, and you could have counted right and down. I just went down and right, doesn't matter. This is 10 and this is 5. So instead of going down 10, right 5, I started here. I divide these each by 5. 5 divided by 5 is 1. So I go down 2, right 1. Let me see if I can carefully plot this. Down 2, right 1, down 2, right 1. Okay. And then I have... Oh. Accidentally hit back. Okay. 1, 2, 3, 4, 5 segments. All right, and they're all of equal length. So you got to pick it. What is it? Find 2 points that partition, that break it up into a ratio of 3 to 2. So you got to go 3 segments, stop, and then go 2 segments. So 1, 2, 3. So that one, and then there's 2 left over. So that one appears to be 1, -2. But just as easily, I could have started at the other endpoint. I could have started down here and gone 1, 2, 3, chosen that one, and had 2 left over. So that's 0, 0. All right, this is Mr. Hunt with Coordinate Geometry Part 2. Thanks for watching.